Modern society operates on a rigid, artificial script: breakfast, lunch, dinner, and snacks in between. We are conditioned to believe that the human machine requires a constant, uninterrupted influx of external fuel to prevent metabolic collapse, maintaining that skipping even a single meal could lead to muscle loss, severe fatigue, or cognitive deficits. Yet, if we look beneath the surface of our modern schedule, we find a glaring biological contradiction. Our ancestors lived for millennia without refrigeration, supermarkets, agricultural abundance, or regular meal intervals, thriving in unforgiving environments defined by unpredictable food scarcity. Why does an organism built to endure prolonged periods of empty space experience chronic systemic dysfunction, insulin resistance, obesity, and lethargy when subjected to the very abundance it fought for generations to achieve? Every time a human consumes food, a silent, chaotic battle begins inside the bloodstream, disrupting our metabolic equilibrium. Leukocytosis, a sharp increase in white blood cell count, occurs almost immediately after eating, mirroring the body's acute inflammatory response to an infection, foreign pathogen, or physical injury. When we eat 5 to 6 times a day, never allowing our digestive systems a moment of rest, we keep our physiology trapped in a perpetual state of low-grade, postprandial defense. The body spends massive amounts of energy processing, sorting, screening, and defending against the incoming cargo, leaving virtually no time or biological resources for internal maintenance. Why would our biological design treat the fundamental act of nourishment as a repeating minor biological crisis unless it was meant to be an infrequent event? The paradox deepens when we examine our complex cognitive architecture. Conventional wisdom says that constant, steady glucose spikes are absolutely necessary to fuel complex thought, reasoning, and decision-making throughout the day. However, the forensic reality of human performance and evolutionary history reveals an unsettling anomaly. Deep focus, heightened sensory perception, spatial awareness, and cognitive clarity do not peak during the digestive phase. In fact, they arrive when the digestive tract falls completely silent, transitioning into a protective conservation state. The physical data leaves us with a massive, unresolved contradiction. Why does our brain unlock its most sophisticated, creative, and sharp processing modes only when we starve the system? The friction between our constant eating habits and our actual biological design cannot be resolved by standard caloric math or basic macronutrient ratios. To understand why high-frequency eating strains the body, we must introduce a completely different physiological framework. The human body is not a basic combustion engine that needs constant fueling to stay running. It is a highly sophisticated, dual-state survival matrix engineered to fluctuate dynamically between consumption and conservation. When you compress your entire nutritional intake into a single daily event, you are not merely cutting calories. You are deliberately triggering the autophagic reset, an evolutionary emergency protocol that shifts the body out of defensive growth and into hyper-efficient cellular recycling and repair. When food is entirely absent for 20 hours of the day, the body's primary signaling hormone, insulin, drops down to its absolute baseline. This sustained drop flips an evolutionary master switch that changes our entire metabolic fuel source. Deprived of external glucose, the liver rapidly depletes its stored glycogen and triggers lipolysis, liberating stored body fat to be converted into ketones. Ketones are not just an alternative fuel source to prevent starvation. They are a premium, highly efficient cellular energy currency that burns far cleaner than glucose, reducing oxidative stress, lowering systemic cellular damage, and providing the brain with a steady, unsplittable stream of uninterrupted focus. The true magic of the single daily meal happens at the 16-hour mark, when the body initiates autophagy, a term that translates to self-eating. Without incoming nutrients to process, cells turn their focus inward, hunting for damaged proteins, misfolded enzymes, and old dysfunctional mitochondria. The cell packages this internal debris, sends it to an internal recycling furnace, and repurposes it to build brand new, highly optimized cellular structures. Continuous eating acts as a permanent pause button on this critical housekeeping process, turning the cellular landscape into a congested, uncleaned warehouse. One meal a day acts as a daily deep cleaning crew, rejuvenating our biology from the inside out. This prolonged fasting state acts directly on our genetic expression, altering the very blueprint of our cellular survival. The stress of waiting 24 hours for food activates sirtuins, a family of signaling proteins widely known as longevity genes. Sirtuins regulate epigenetic modifications, repair DNA damage, protect against mutations, and suppress the pathways responsible for accelerated cellular aging. By compressing our food intake into a tight window, we mimic the environmental pressures that forged our species, forcing our biology to prioritize survival, longevity, and structural resilience over cheap, immediate cellular replication. Furthermore, this single meal pattern triggers a powerful hormonal cascade designed to preserve human vitality and physical strength. During prolonged fasting, human growth hormone levels surge dramatically, working to protect lean muscle mass and bone density while accelerating fat burning. At the same time, brain-derived neurotrophic factor increases, stimulating the growth of new neurons and strengthening synaptic connections. This dual-action response ensures that even when resources are scarce, human physical capability and cognitive processing remain at their absolute peak, showing that our biology was optimized to hunt and perform on an empty stomach. Our immune system also undergoes a profound transformation during this extended period of fasting. As the digestive system goes dormant, the body initiates a process called apoptotic clearance, purging old, damaged white blood cells and stimulating the regeneration of entirely new immune cells from hematopoietic stem cells. This metabolic pause essentially reboots our natural defense systems, shifting metabolic energy away from digesting complex macromolecules and focusing it entirely on searching for intracellular invaders, damaged tissues, and precancerous cells. When you look into a modern mirror today, you are looking directly at an animal designed explicitly for the Ice Age. We live in an architectural landscape dominated by processed carbohydrates, refined sugars, and industrial plant oils, yet we carry the exact same hyperacidic gastric chemistry as an apex scavenger. The modern chronic health crisis is not a mystery. It is the natural, inevitable friction of an obligate hypercarnivore trying to fuel its advanced biology with the very starvation rations its ancestors spent millions of years trying to avoid. We changed our world, our fields, and our grocery stores in the absolute blink of an evolutionary eye. But our bones, our stomach acid, and our brains are still waiting on the edge of the ancient savanna, waiting for the massive hunts of the past to return.